Okay, on the back side of your notes, we're still in section 5.4. Now we're going to look at just graphing the square root functions themselves. Let's just say we start off with the original square root function. We're not finding it as part of an inverse, we're just asked to graph a square root. Well, the equation of a square root function is very similar to a quadratic. We know the quadratic in vertex form was y equals a times x minus h squared plus k, where h and k was your vertex. Your vertex here was h comma k. Okay. Well, here our square root function looks a little similar to this. We have this h and this k, and our a here is 1 currently. This is your value of a. And all the problems we're going to do in this course, a is going to equal 1. A doesn't have to equal 1, but to keep things simple for yourself, we're going to keep a as 1. Now, the h and the k is still going to represent the vertex. And remember that the square root looks like a square root sideways parabola when you graph both a positive and a negative value. Okay? So this is h comma k. So the h value will be the opposite sign of what you see here, and the k will be the exact same sign. And you can tell where h and k is similar to how you found it on the quadratic. Here h was inside the parentheses being squared. Well, here h is underneath the square root. The k was on the outside of the squared. Here k is on the outside of the square root. Okay. So on number 1, let's first start by finding our vertex. So your vertex is going to be the point. Well, the x is underneath the square root, and it's going to be the opposite sign, so that's 2. And the y value, or the k here, is going to be what's added on, so there's nothing there, so that's 0. So our vertex is the point 2 comma 0. Now, unlike quadratics, where we put the vertex in the middle, here we put the vertex in the middle. On the square root, the vertex is going to be at the top of our chart. Okay. And the reason why, let me explain that, is because the vertex here on the far left, and then we're keep moving to the right. So here the vertex, there was x's on both sides. Here there's only x's on the right side. There's no x's on the left. So we don't want it in the middle. So on our chart here, we are going to put 2, 0 as our vertex. This again is our vertex. Okay. And then we need some other points. Well, what are some nice square root values? Well, when you plug 2 in, you get 2 minus 2. That's the square root of 0. So square root of 0, that's a nice square root. Well, what's the next nice square root? Well, the square root of 1, because the square root of 1 equals 1. Next nice square root is the square root of 4. That's equal to 2. Then the next one after that would be the square root of 9. That would equal 3. These are nice numbers. Okay? So I'd like this square root to turn into a nice number so I can graph it nicely. Well, when we plug into 2, you get the 0. We've already done that one. So what number would you plug in for x that would turn the square root into a square root of 1? Well, that would be 3. Because 3 minus 2 is 1. And then the square root of 1 equals 1. So the point 31 is a point on our graph. Notice on this one there is no plus or minus in front of that square root. So this one, we're going to have a point, and then it's going to be going up. We're not going to have the bottom part of this sideways parabola. We're only going to have the upward part. So now let me get one more point. So let me try to make this a square root of 4. Well, what value of x would you plug in to turn the square root into the square root of 4? Well, that would be 6. 6 minus 2 is 4. Square root of 4 that turns into a 2. So let me plot those points. We've got the point 2, 0, we've got the point 3, 1, and we've got the point 6, 2. And we know this is our vertex, and we know this thing's moving up, and it's going to head to the right. So there's your graph of the positive square root of x minus 2. Now if we had a negative value there in front, this would actually have been going down. Okay? So that's the graph. But before we move on to the next one, we're going to start asking you to start stating the domain and the range. Well, the domain, as you might recall from the function unit, represents the x values, and the range represents the possible y values. Okay? So, as we look at this graph here, and we know the fact that the value underneath this square root needs to be positive, because what would happen if we went smaller than x equals 2? If we plugged in a 1 for x, this would be 1 minus 2, which is the square root of negative 1. Well, what happens with the square root of negative 1? Let's look. Second function, square root of negative 1, what do we get? We get an error. It says non-real answer. Okay? So the square root of negative 1 is a non-real answer. Therefore, we can't plot any non-real points, so we can't go any smaller than the square root of 0. So x being 2 is the smallest possible value of x, and then it has to increase from there. So for our domain on this problem, x has to be greater than or equal to 2. So we can start at 2 and it keep getting bigger and bigger and bigger because the x keeps going this way. What about our range? Well, your range are the possible values of y. So what's happening to y? Well, when we start at x equals 2, our y starts at 1, and what's happening to our y values? The y values are getting bigger, 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 bigger. As x increases, y increases. So our y is going to get larger, but it could equal 0. So it's greater than or equal to 0. See how it starts at 0 and goes up? That's your y. Your domain starts at 2 and moves to the right, so it's greater than 2. So that's the domain and range, and you'll be asked to do that on quite a few problems as we move through the rest of the course.